for having these great talks. Look at this. We got our speakers are here. Welcome, Kit, Michael, Tapasvi. Welcome. How y'all doing?
Doing great.
Great.
Thanks for having us.
Yeah, super excited to have you all here. We got some great folks in the chat. They're excited. They told me they're going to grill you with all the hard questions, make you sweat about all things cloud. So super pumped. Without further ado, you all know how this works. If you've been joining the last couple of sessions, if not, ask us in the chat. Otherwise, I'm going to turn it over to Tapasvi. Kit, Michael, take it away.
Thanks, man. And thank you, Defense Unicorns, Linux Foundation, Catalyst Campus for hosting us. Welcome to Cloud 101. I'm going to kick this off with my fantastic co-hosts introducing themselves. Michael.
Hey everybody, Michael MacFadden with Sigma Defense. I'm the CTO there and super excited to be talking to everybody today.
Hey, good morning all. Kit Plummer. I don't know if I'm a cloud and platform guru, just a software engineer, but most recently was director of DevSecOps at Microsoft Federal.
I'm Tapasvi Kaza. I'm the CTO at Vivsoft. We try to solve a lot of the complex problems in government using emerging tech. And with that, I'm going to start off our presentation. This is our agenda. We'll talk to you about what is cloud computing, how it's a bit like craft beer in some ways. Why should you care? How do you get started? Do you need new skills to consume it? And how can we help? With that, what is cloud computing? I think we're in a Linux Foundation conference, so it goes without saying that we should acknowledge that most of the cloud, it's Linux servers essentially. So it's a great phenomenon that's changing how we build and run our applications. It's a way of consuming services, whether it's the traditional compute network storage, databases, those kind of applications over the internet, and that's primarily what it is. Kit, Michael, feel free to jump in at any point.
Yeah, I think part of the cloud is just what we call location transparency, right? Where you just don't specifically know or are sensitive to where your server physically is, right? And it might be in a remote data center. Ultimately, there's a data center somewhere, there's a server somewhere. But really, migrating to the cloud is just making sure that your systems are sort of location transparent and you're not really specifically caring where that workload is running.
Agree. In the context of government, it takes on many kinds of flavors. And Kit has worked through a lot of these in his journeys. Kit, can you give us a sense for what these terminologies actually mean? And how does this translate into how government consumes something like a cloud platform?
Yeah, obviously there's some complexity with cloud computing in general, but it probably grows exponentially as soon as the government touches it, just like all things. But to kind of maybe help make the connection in terms of government using cloud, there are a couple of key things that usually revolve around controls or requirements for consumption by government. And terminology you might hear FedRAMP, which is a way for service providers to gain compliance or accreditation to be available on cloud systems. And then each of the sort of hyperscalers are providing cloud capability at different access levels. I'll talk to the ILs in just a second, but sort of targeting sovereign usage, and in most cases, what we're talking about here, the U.S. federal government space. And so, I'm not actually sure where Oracle is in terms of offering cloud capability, but AWS, Azure, Google Cloud all have gov-specific environments that are, for all intents and purposes, providing services to government consumers. And I guess to highlight the slide here, Those services are available at different impact levels, IL being impact level, defined by DISA. And that's usually some kind of relationship to the data and the context of the software and the services that are available at those different impact levels. Usually, super generalization here, IL2 is completely unclassified, usually public, and more often than not means that it's either a commercial service like regular old, AWS or Azure. Yeah, thanks, Arthur. I'm glad that Oracle's catching up. And then it might also mean that there's actually IL2 capability in the GovCloud environment. That means it's been FedRAMPed, or the services that are available in that IL2 ecosystem are FedRAMPed. IL4 associates to CUI, controlled unclassified information, old school. For those of us who've been around for a while, FOUO. IL5 is some designator that sits on top of the IL4 that indicates national security requirements. And I'm not 100% on this, but I'm going to say it anyway. That means that there are actual some sort of separations of concern in the actual physical infrastructure, so that it's not actually the same hardware and networking and capabilities that are shared within the commercial or the gov clouds at IL2, IL4. And then IL6 is another enclave with gear, physical infrastructure supporting secret or above. And I'm pretty sure that AWS and Azure are the only ones that are operating at IL6 right now. I'm sure there's work both at Google and Oracle to get there, but as far as accredited systems that are available for government use, it's just really AWS and Azure. And then, if you're coming at this from the government, or specifically Department of Defense or the intelligence agencies, your cloud service providers that sort of sit in front of the hyperscalers, like Cloud One, for example, that are sort of managing account level access to the different IL levels and setting up the sort of IDAM aspect, how you control access and authorization to these systems.
Very cool. So the question, I think, for folks who are brand new to this environment is, what does that really mean in terms of how is it mapping to a data center? I used to have very similar capabilities on the physical infrastructure that I had. So what is the difference? And primarily, I think it breaks into three core areas. One is you're not paying for all your resources upfront, and you can pay as you go. The second big difference is you get access to very cutting edge technology that's packaged for consumption and makes that user experience of getting something going pretty quickly. And that leads to faster innovation cycles, especially in the government. And that kind of is a different mindset from actually racking, stacking, and waiting for some compute to actually come to the hands of the developers before you can do something. And obviously, you need resources based on what kind of workloads you're running. And sometimes you might want to scale up or scale down, depending upon your traffic, the patterns that you're seeing within your applications themselves. And these are some of the ways that the cloud is kind of different from a data center. Again, Michael, you've kind of worked through these kind of environments and worked with various technologies that enable this kind of environment to get spun up. Do you want to talk to the automation side of things? And
yeah, so two things. I think one of the big things to think about is, as an organization, what is your primary mission and what is your expertise, right? So if your expertise is building and delivering software, do you want to worry about, do I have redundant power infrastructure? Do I have two internet backbones coming in here that can, guarantee, connectivity if one ISP goes down, right? And so if that's not really your core competency, you're probably looking at, hosting somewhere else, right? And not building your own data center. And in government, really, we toggle between building our own data center in the cloud. We really don't, in government, go too much for that co-location where I'm just putting servers in other people's infrastructure. And so as a government focused person, do you want, you're gonna pay, either have an on-premise or cloud. And so really it comes down to, what is your core competency, and what is your focus? The other thing that I would say is, if you knew for sure that you were going to need X number of servers with X number of CPU and memory, building something on-premise might be cheaper if you had a very static and predictable workload, right? But if you don't, and you have capacity that ranges up and down, right, then when you build your own data center, you have to build out your own data center for that max, sort of consumption, max utilization. And what that means is you paid upfront for a lot of stuff that is probably going to be idle a lot of the time, right? And where that relates to DevSecOps, bringing it back to our topic here, is that a lot of DevSecOps workloads are very peaky, right? If the developer hasn't checked anything in, I'm not running any builds, right? If we're not pushing a new application, maybe we're not running a lot of new automation workloads, right? And so I think DevSecOps and cloud works really well together, where you can use that cloud scalability, scale up, down, to follow sort of the peaks and valleys of sort of your DevSecOps and software lifecycle.
Absolutely. And that kind of leads into the other dimension of it, right? You have this capability of using it on demand, but like craft beer, cloud computing comes in many flavors. Some of this makes sense for you, but ultimately it's about how much control you want to take within those environments. You have different styles of cloud. You have infrastructure as a service, which is the lowermost. You have a lot of control, but again, it's a lot of management overhead to maintain the infrastructure that you have. You have PaaS services, which is platform as a service. Essentially, it gives you a packaged and a very different flavor of cloud, where you don't have to manage the core underlying infrastructure, but you still get capabilities which are cutting edge. And finally, software as a service. This is the domain of end users directly accessing systems that are already stood up and running with very specific purposes. And it's this kind of trade-off that you're essentially dealing with. And I'm sure, Michael, you kind of run into different kinds of teams in the government, and there is a spectrum there, right? What is your take on the balance between the level of control and how much balance of a mix do you really want?
I'll add a little bit of color here. So I think for a lot of people, especially if you're just coming to the idea of cloud computing as a potential, that amount of control that you're willing to distribute to somebody else is a little bit complicated. But I think in reality, what we're seeing is at the IS level, at the bottom there, that's actually logically, more often than not, logically distributed across both private and public cloud capability. So all the hyperscalers now have functionality that does logically distribute resources, both compute, storage, and maybe to a degree some notion of networking, from cloud to what might be called edge or on-premise. And there's also the I guess maybe varying degrees of hybrid and whatever that means. But I think in a lot of cases, that we're finding that data control or data rights, dictates things and creates new requirements for what's allowed to actually be stored in the cloud, the holy thing above us, versus in our own data centers and things like that. So I just wanted to make that point that hybrid or some notion of distribution across public and private resources is very much a piece of what cloud computing is today.
Yeah, I totally agree. I would add that I think at least from my perspective, right, others might have a different perspective. I think we're seeing pretty effective use in the government space of commercial IaaS and also commercial SaaS. So we see the government using things like Office 365 when a vendor has taken the onus on them to get an IL2 or IL4 or IL5 SaaS service, right? So we see effective use of that in the government. We also see effective use of sort of commercial IaaS, right? That's just sort of, hey, we're up in AWS, we've got APIs that we can spin up VMs in Amazon or Azure or Google Compute, right? And people that migrate from a physical data infrastructure who already have the IT administrators, a lot of times opt for that IaaS as sort of a first, migration. Where I haven't seen as much adoption is sort of the commercial PaaS space yet, right? I think though because a lot of times it's not worth the commercial vendors to go through some of the certification and ATO, EMAS control stuff in their PaaS stack. So when you try to deploy into their PaaS and say, okay, how do I now document where those controls exist? It becomes a little harder as somebody trying to get something ATO'd. But I think that's where organizations like Platform One have come in, for example, or Black Pearl and the Navy, to try to provide that PaaS layer with sort of the government flavor and the accreditation space to kind of slot in right in that middle space.
Very cool. And again, to one of the comments you made, Kit, this is again getting very real in terms of where does the compute actually happen? And the cloud and the edge are two dimensions of that, where there will be some workloads where it makes sense to run them in a edge environment, even though there is stuff flowing back into the cloud, especially with edge IoT systems. There might be mission systems out there that require that kind of edge compute capability. Even though you're building on cloud, you kind of deploy. Do you want to talk about some of the flavors that you've seen? What kind of tech actually makes sense in these two dichotomies, so to say?
Yeah, I'll comment on this really quick. I mean, if we're talking about government or defense or intelligence systems, or even just FedCiv space in general, I think we're finding that these four underlying sort of tactically edge oriented things, whether it's a stoplight or a mobile device, they're a fundamental piece of the computing, storage, and even networking infrastructure that we're operating on. And I think the operational use cases are just now starting to dictate where things actually run and execute. For example, the use case that comes up a lot is like we generate so much data at the edge or via sensors to make an intelligent decision. We can't send all that data to the cloud anymore because there's either too much data or there's lacking in bandwidth or connectivity things that complicate that we have to move the processing to the actual edge to actually have a useful decision to be executable, right? So it's sort of the standard IoT topology. The application or the applied machine learning capability that's really starting to happen. It's mandated, the requirements that we have to be able to move models to the edge and execute there. And so from a DevSecOps perspective, it sort of creates a bigger challenge in, if we're talking about using DevSecOps for generating, cloud native, if you will, applications that are going to run natively in the cloud. Yeah, that's great. But in reality, that's kind of the simple example. We need to start rationalizing how we're moving data that's going to be used to train, test, and validate, models in a machine learning operations kind of environment. And then also the ability to get the models and applications back out to the edge because, well, that's where they need to run. And then that full loop needs to exist, right? So we're really starting to look at DevSecOps extending, across this logical distribution of all resources.
Yeah, and I'll say there's a bit of a symbiosis between cloud and edge, I think, especially if you're talking IoT with large numbers of devices, be it mobile phones, for example. When nothing's going on in the world, maybe those IoT devices aren't doing a lot. When something is going on in the world, maybe you get a lot of traffic all of a sudden from a particular geographic region and you need to scale up. And that dynamic between, larger data set analysis, model building in the cloud, pushing those models out to the edge devices to update them, letting those process locally on smaller subsets of data. And then the fact that cloud can sometimes give you that location transparency as well. where, what region of the country, for example, those workloads are running, maybe can be optimized for, where those edge devices are also trying to send and receive data from. So there's a bit of a symbiosis, and those two things are definitely sort of evolving together.
Absolutely. And Douglas, your question about the actual running of applications without connectivity, with resource constraints, that's a great use case, and I think that's the more common use case, especially on submarines or other kinds of edge infrastructure. And Kit can come back and talk about it, but essentially these are some of the use cases that even Michael is looking at on the Navy side, and we'll circle back and address that. So it's very uncommon to talk about cloud without talking about the migration strategies, and this chat pretty much sums up the kind of complexity that different teams have to deal with. Like, what is the path? How do we even get started? What kind of options do we really have? At least my experience has been that it's not a simple answer. A lot of it goes into, do you have developers? What kind of skills do they have? What kind of access do you have to the underlying code that's running today? And you might hear microservices is the answer to everything, but in reality, there's a lot more to it, and a lot of thought, which I think other folks addressed upfront as well. Michael, Kit, your thoughts on these strategies?
Yeah,
Go ahead, Michael.
I'll go.
You go.
Yeah, I think one of the things, right, like this really is a decision matrix, and there are pros and cons. And I think, a lot of people start out their cloud journey with the lift and shift mentality, right? Of maybe I have some virtual machines, maybe I'm coming from bare metal, but how do I lift and shift that architecture and put it in the cloud? And if that gives you some benefit, that might be a logical first step to get there, right? But a lot of times when we move into new technologies, like when we saw the DoD starting to adopt virtualization, they took their physical servers, they virtualized them, and then they put those VMs on one hypervisor on one on one server, and they didn't get the benefits, right? We're seeing the same things with containers. We're taking something that wasn't a server that we then put in a VM, and now we wrap that whole thing up in one big monolithic container and deploy it in Kubernetes. And so we're adopting these new underlying frameworks and paradigms without asking the question, hey, am I fully taking advantage of that new framework I exist in, right? And so, when we look through these paths between rehosting, replatforming, maybe refactoring, can I break my system up into smaller pieces? Can I automate different pieces of it? Can I instrument and metric and scale out differently now that I'm in a cloud, that I have APIs from an IaaS perspective? Like, these are all questions that we need to ask ourselves, and you might take multiple paths through this diagram in different phases of your cloud migration. So you might rehost today while you're refactoring for tomorrow, and then deprovisioning down the road.
Yeah, I'll kind of agree 100% with that. I mean, having been around long enough to sort of be at the front end of what we know as C2S, and sort of being in the cloud game early, and even the DevOps game early, I think we sort of get this wrong 100% of the time. I think we're, if the initial question is lift and shift or refactor, you're probably already messed up. There are already challenges that you're not going to be able to overcome. I mean, rapidly processing this mental calculus in my head to try and say the right thing right now. Like the point that I want to get across is that you probably need to decompose your system before you even start thinking about, migration. Think about what your data storage requirements are. Possibly move your data first. Think about where your users are. Think about performance requirements, and what you actually want to get out of the cloud. I think if your approach is like it's going to be cheaper, that, like you said, Michael, that's a little bit of a challenge, because if you literally rehost, it's going to be more expensive, right? You're gonna lose money. And Tapasvi, as you're talking about, the skills required to actually go through this process, it's not standard, it's not ubiquitous yet. I mean, And maybe the hyperscalers in some ways are making this more complicated than it should be, because they all got their own tool chains and tool sets, and the IAC game, the infrastructure as code game, is rapidly evolving as well. It's a big mess. The reality of the situation is we need to for sure just sort of justify the move. Make sure we understand what the total cost of ownership is once we're moved, and then kind of compare. If it's a a factoring game, there's for sure optimum ways to go about that. The strangler pattern, which was kind of mentioned earlier today, you got to lift and shift first before you can start refactoring. So I think there's lots of problems that exist, and we tend to make it harder than it should be. I guess want to, having said all that, just kind of highlight that I think the elasticity goal, the sort of I guess idea that you can update your systems quicker and faster if you're running on other people's infrastructure, kind of coming back to the ATO conversation a little bit. Like we can't ignore that. That's definitely not mentioned here. I think that's the biggest maybe an administrative thing that we're missing, is that it's one thing to be cloud native. It's another to actually have the ability to distribute your ATO and gain the benefit of the platform provider or the infrastructure provider providing a big chunk of the RMF controls, platform provider providing another big chunk, and then the potential of having something be continuous, right? At the end of the day, the mental calculus is about continuously delivering, because warfighters need new updated capability. We need to plug and fix security holes as quickly as possible. And that's not achievable in a timeline that's rational if you're monolithic and you have a data center that's sort of isolated and isn't just the load for operations isn't distributed. All right, there's my 2 cents.
Yeah, I want to just foot stomp one thing that you said there. I think you said a lot of important things, but the thing that really jumped out at me is if you can't answer the question why you're moving to the cloud, and furthermore, what is going to be better about my application and its delivery after I move to the cloud, right? If you're just moving to the cloud because something came from on high that says everybody move to the cloud, and you just do that lift and shift and don't really know why and what you're hoping to get out of it, you're probably just going to wind up with a more complex and more costly system, right? If you don't understand why and then do the things to move you towards that why.
Totally agree. And both on the FedCiv side and on the DoD side, right? Our experience has been that you truly need to understand, like Michael, you said, the why of it. And also, what is a pragmatic approach, right? Can I look at the pieces and get some of this ready to go versus starting everything from scratch and trying to build everything bottom up? There is enough out there now for you to have a fairly decent starting point, and you can get your developers more used to the concepts of Git, the concepts of automation, and gradually pick one thing to figure out what it looks like. I think that the value of that goes a long way, because you get to see where the things break, what gaps do you have. And again, it's a complex ecosystem of tools, and people are at different paths in that journey. It should make sense to what you're trying to do in your environment. So these are the 2 things, at least we can agree, give you that kind of path to transition, right? Start with smaller pieces of code and get the teams to understand this concept of the infrastructure is no longer some bulky piece of metal that you have to touch and manage. Somebody is doing it for you. That's the cloud part. But still, there are ways to interact with it, with infrastructure as code that defines what is this desired state that you're trying to spin up, and how do you articulate that in small chunks of code. Similarly, this notion of having microservices that let you deploy smaller chunks of code faster, so that you have more control over the delivery cycle and you have more confidence. I think these are some of the pieces of the puzzle that you have to figure out as you go. What's your take, Jens?
Yeah, I would say the other piece of that is that as you break down your application into smaller bits, your unit of scalability becomes more granular as well, right? When I need to scale something up, am I scaling up that big monolithic thing just because one piece of it is being stressed, or can I, scale up the particular, API or submodule that's being stressed as well? So there are some, nice alignments there with the scale out strategy. When your unit of software is smaller, you can kind of scale with a scalpel instead of a sledgehammer.
Agree.
Did we lose Kit?
I think we lost Kit. He can circle back and join. But this is, I think, where we assign everything to Kit. The reference architectures, right? For a government team, where do we get started, and what does that really look like? Essentially, there are two reference architectures that come to mind. One is the secure cloud computing architecture, which lays out the different pieces of that cloud environment. What is the virtual data center management stack? What is the security stack? How do you get into this environment? That's one piece of the puzzle. And the second is, now that you have that kind of environment, how do your applications actually start running there with DevSecOps, the shift left security, the baked in automation, and the DoD enterprise DevSecOps reference design? It addresses that portion of how do you automate and what kind of tooling do you need to have in place to satisfy compliance needs, to satisfy the security, build time, runtime, operation of your applications. And the two reference documents give you a good framework to start thinking about it. Michael?
Yeah, and I would say, we've all probably read many government specifications and memos and documents, and I would say these two are actually pretty good, right? In terms of, especially on the enterprise DevSecOps reference design, it gives you a lot of good conceptual frameworks to just understand the different moving parts, especially early on in the document, right? So if somebody just basically read the executive summary of that document, they'd get most of the details on the moving parts that you need. You can, of course, drill into the later sections of the documents, and then then they kind of refer to some more specific reference designs, like the zero trust architecture that's coming out, et cetera, et cetera.
Mm-hmm.
But these really are worth reading if you want to get your head around what the moving parts are here. Welcome back, Kit.
Thanks. Sorry about that. Technology, gotta love it. Real quick, I don't know if you mentioned it, but I think I just saw the link go by in chat that Gerald had posted. But there's an interesting thing happening right now. There's the idea that there's a singular reference design. Well, being reference is probably interesting in itself, but there's a single one source of truth for zero trust, or how to do DevSecOps is probably, I would say, ignorant or arrogant. What happened is Microsoft in collaboration with DisAHack published a second reference design, which actually doesn't include Kubernetes. And it actually shows a pathway using commercial GitHub deploying across IL2 impact level 2 cloud infrastructure, and having all of the required scanners and all the different adjudication pieces in place that would enable you to get a continuous ATO or a continuous RMF set up across IL4 or potentially even to IL5. The hope is that somebody will take that reference design and instantiate it in a way that would enable delivery from commercial source code, commercially hosted source code in, for example, github.com or gitlab.com, and having that code flow all the way to IL6. I think that's a really important landmark. It's identifying, I would, battle with Nick all day long about whether Kubernetes is the future in 5 years. But I think the reality is there's a lot of software, whether it's mobile, whether it's going to end up in a microcontroller, in a remote control device, or wherever it might be. We need to start thinking about a much larger ecosystem of software that includes the complexities associated with dev tests and integration and what that means and who controls the platform. I think that's also a little bit of another landmark happening, right? This idea that there can be more than one platform, one like environment, Black Pearl, or that they're going to be domain specific, that they're going to have the ability to potentially provide different levels of interrogation or introspection into what's being built and delivered and tested and continuously tested in sort of that production model. I think that's also really exciting to see. I'm very, very, I guess, adamant and hopeful about what JWCC brings, and having all the major hyperscalers sort of representative and being able to drive the competition. And I'm really hopeful that all the cloud management offices, Cloud One or ECMA, and what's happening in the Navy and to a degree the Marine Corps, I'm very, very adamant we're going to see more reference designs that enable an authorizing official to have confidence that the platform they're signing off on, their production environment that they're signing off on, is actually sort of compliant and all grounded in the same levels of zero trust and DevSecOps.
Okay, that's a great point, right? So we are seeing the emergence of multiple software factories, which are flavors of this core belief that you have to bake in security, you have to automate deployments, you have to release in smaller chunks of code. Platform One, which Austin is going to talk about later in these sessions, is sort of one Kubernetes-based ecosystem which codifies that kind of automation. Batcave is the FedCiv side of it. We are a part of this team building a similar DevSecOps platform for Centers for Medicaid, Medicaid. Michael, you're deeply familiar and a major part of building out Black Pearl in the Navy. These are the kind of codified practices that enable you to take advantage of one level of automation that's implemented. But what are some of the unique challenges that you've encountered when you deploy these kind of factories?
I think the biggest thing that I've found is the concept of reciprocity from a certification standpoint is pretty tricky, right? It doesn't seem to matter yet how much policy or memos get sent out at the DoD level. The different services take different views of both how to certify the software factory environment and also how to think about the continuous ATO of the software coming out of said environment. So we have challenges at both levels. And then even within the services, you have certain groups that are, say, providing manpower and logistics applications versus weapon systems. And the level of scrutiny and thought that goes around, software assurance in general bleeds over into how they think about these things. And you wind up with different authorizing officials having very different views. So, adaptability, I would say, is a key.
Yeah, we hear reciprocity thrown around for good or bad, but I'm hopeful, again, adamant and hopeful that we will have. This might sound totally strange because I'm a true believer in that you can't spell disappointment without DISA, but I'm very adamant and hopeful that DISA and their role, in their new role, and Rob Wiedmeyer's new CSE help us sort of build this trust across the different agencies and departments internal to some of those agencies. So, I mean, they're good signs. I'll leave it at that.
Yeah, I think this goes back to another question that Hope asked on chat, which is how do we get that kind of acceptance to connect different sites and developers and different government sites to get the kind of skill that you want? Essentially, it's a security and truly understanding what does it compose and what are you exposing when you start connecting systems, right? I understand why it's complex, but maybe there is a framework in the future that lets you define that, boundary with zero trust with other things. And they might be hope that, you can get that kind of reciprocity in code. So we talked a lot about what is the cloud, what are the kind of problems, how do you get started, what are reference architectures. This, I think, is a very important question for teams listening and trying to get a handle on, I have skills, how do I map it to this new world? I think the good news is a lot of the skills are very easily transferable, in that you're still dealing with Linux servers, you still have firewalls, you still have the same kind of concepts, whether it's storage, network, compute, security. The API part of it is the sort of different dimension of how do you configure it with code. But at least I think there is a easier path to getting into this world by taking advantage of your existing skill sets. What do you guys think?
Yeah, I think this is an interesting thing. I think if there's many lessons to learn from Kessel Run, for example, but I think even before Kessel Run, seeing what happened at NSA and then what happened in early days with C2S at NGA, this idea of platform capability being delivered to developers, right? Really put the problem-solving capability into the problem owner's hands, enable rapid development, user-centered design, all the goodness that is those things. That I think we've kind of lost our way a little bit on that. I'll make a statement again, maybe a little bit cage rattling here, but as a developer, I don't want to know diddly about Kubernetes. I want to know my language. I want to know my problem set. I want to interface my customer, and I want to deliver a solution. I shouldn't have to know the intricacies of what happens after my code leaves the CI/CD pipeline. I think we've kind of shot ourselves in the foot a little bit by that, right? Because and I'm not trying to say that developers aren't responsible for their code getting to production. That's not what I'm saying at all. I think it's just a matter of there are too many verticals that are very complex, and individuals will struggle to deliver this stuff if there's that sort of mentality. I want to see more pass capability. I want to see domain specific pass capability. And then, let's grow those cloud skills. Let's get platform engineers. Let's grow them. Let's train people to focus on what production means, operationalization of AI, ML, machine learning operations. I think those things we need to start digging at. Let's not keep shooting ourselves in the foot by thinking that there's a single person that can do full end-to-end all these things.
I totally agree, Kit. And some of it, at least, we've tried to tackle this problem at Vivsoft. We have an accelerator called NBuild. This is the plug part of it, but essentially, it is our attempt at solving that abstraction layer, right? How do you let people focus on what they're really trying to do and abstract away the underlying, mechanics of, this is the kind of stack I need, this is the kind of automation I would need. We think that there is a use case to abstracting at the right level and pre-packaging that in a particular way. I'm not saying this is the only way. There are other technologies that let you do similar kinds of things. If folks have not looked at Crossplane, that's another very interesting tech, which is thinking about this kind of self-service abstraction. But that's sort of our take on enabling developers to focus on what they really need to do. I'm going to put a couple of links in chat. This is, some of the videos and our content in terms of enabling that kind of deployments. But even without this, I think the point that you're making, Kit, is how does that environment of developer deployment cycle get to the bare minimum, so you can not worry about all the intricacies of that pipeline. I think that's what you're hitting at. Michael, feel free to jump in. We have a few minutes to talk through this, I think.
Yeah, I totally appreciate the value of so a couple of things that were said in chat. Allowing devs to focus on delivering functionality to their users, meaning the features and capabilities they're building, and let the ops ops team, right? I think they're, again, being around in the DevOps game back in 2010, early days at Velocity, the conversation was very much about, burning down the wall in between dev and ops, right? We're sort of recreating that, right? And we're actually adding a third one if you talk about the platform or the delivery apparatus, and there being a third entity like a platform engineer. I think we still need to burn that wall down and make sure that these organizations, because it is dev organization, ops organization, ensuring that we're crossing those things. There's many tools. I think NBuild is one you mentioned. Another that will, increase parity between production and dev by standardizing the way that they're defined, and ensuring that they're the same. Michael, I kind of want to tee one up for you because I know you're in the game. Going back to the question that was asked in Q&A about, a tactical system, like how does all this stuff apply to something floating or with little to no connectivity? What's your take on cloud in those sort of ecosystems?
Yeah, I think the two things is, to really get towards cloud delivery, you add a whole bunch of complexity. You've got data rep sync issues. How do I make sure the data I need is on the platform I need? How do I move between connected and disconnected states? So how do I build my software so it'll reach back to the cloud if it's there? If not, look locally. If it doesn't have locally, it's going to not just crash. The delivery of software, that could require hardware in the loop testing. It could require, that parity between dev staging and test, which, your cloud-based test environment may look a bit different if you're not careful from your tactical system, right? And then the last thing that I'll say is the tactical folks, especially in sort of weapon systems, they come from very statically provisioned systems where they're thinking about redundancy in terms of, I have a server on the right side of the ship and I have a server on the left side of the ship. So if I take a torpedo blast on port, I still got my redundant thing over here. And they're very used to knowing what specific workloads are running on what specific servers and where specifically they are. So when we talk about adopting cloud native architectures and then moving that to these tactical systems, that whole paradigm just is very foreign to that entire community. And so there's some socialization and understanding that community needs to go through. But then also we as engineers need to understand, well, what constraints are those folks trying to operate under? And do I have to change some of my architecture or my platform to meet those constraints?
We'll take just one more question if we got it, or if you guys have anything else you want to close with. Now's your chance.
So we really thank the opportunity, and it's great to have this conversation. Again, cloud computing is sort of the glue that binds a lot of these topics. No tech topic is complete without a reference to Lord of the Rings, I guess. So I hope the rest of the team enjoys the presentations. There's a lot coming following our presentation, talking about automation, platform one, lineage, how do you do NIST standard focus compliance, how do you do edge computing, AI, ML. This is a fantastic lineup, and thanks again, Matt, for giving us this chance.
Yeah, thanks everybody for your time today.